Hello and welcome everybody. Good morning, good evening, good afternoon, and thank you for joining to another Neo4j Live. Today the topic is infrastructure mapping, and I'm very happy to have Chad Close and Zach Probst from Intuit join me today. Hi, gentlemen. How's it going?
Hey there.
Hey, I think Chad, I mean, it's got to be said, your hat.
Yeah, so this is Bidoof. He's our mascot, and I wear him in honor of our security org, and specifically our boss, who he uses this silly hat as a way to make security more fun and engaging. So we can't have this live stream without his name is George. He's not the
George.
original. He's a clone, but Gabe Gallagher is definitely the inspiration behind this silly hat.
It's amazing. It's super cool. Behind the scenes, when we were chatting before we went live, I said it's a shame that Neo4j doesn't have a mascot, because I really love a mascot hat now. That's I don't know what would that be, an octopus or something. So that could be fun. But you know, that's a really cool hat.
Well, thank you. We love him. He's made it to very high levels in our org, and I'm sure we'll talk about him more in the future as we build a world-class security organization.
Yeah, that's good. Yeah, before we dive in, I'd like to mention briefly that we are hosting a couple of trainings coming forward. So if you're interested in Neo4j hands-on training, then go to neo4j.com/event and check out the training schedule there in 2 weeks, I think, time. Yeah, 15th of March, we start with an intro session, intermediate Cypher the week after, geospatial routing applications the week after, and then a short break, and we finish off 12th of April with Spring Data Neo4j. So if you are looking for something more hands-on, then that's where you need to go. And I post a link into the chat as well for this special online live series of trainings, of workshops. But now I guess let's start with the actual topic. It's been, I think, well, in the Medium blog post that sparked this or that led to the stream is when Chad, when you were writing this blog post about how you use Neo4j and Akamai to map external attack surface. I can also post that link in chat. That's when we started talking, and then we came to this stream. But I guess your background didn't start there. So maybe before we go into the topic and talk about attacking infrastructure and infrastructure mapping and find security and vulnerabilities, and where George comes in all of this, maybe you and Zach, you want to say a few words about who you are, what you do, and what you currently do besides.
Sure, Zach, you want to go first?
Yeah.
Sure. Yeah. So hi everyone. My name is Zach Probst. I'm a senior software engineer here at Intuit. I've been working here for a few years now. I've lost track of how many, but a couple. So I didn't start out in cybersecurity originally, although that's what I have my degree in out of college. And then I linked up with Chad, and we started taking over the world in the cybersecurity group, building all this cool stuff. So. That's me.
Yeah, so my name is Chad Close. I've been with Intuit since 1999. I've left a couple times, but come back. I always feel like I'm coming home. So I've been with Intuit for a very long time. I started as an operations guy, watching the monitors, grew into the sysadmin group, eventually made the transition over to DevOps in software development, and now I've been working in security since 2017. Specifically, and have really enjoyed learning more about security, and find that my ops background helps me in a lot of ways to understand security better. So that's kind of me. Yeah, I'm excited to be here. Alex, I really appreciate you reaching out and giving us the opportunity to chat with you and talk about some of the stuff that we're really passionate about. This infrastructure stuff is really near and dear to my heart, and being able to see how Neo4j helps us and expands our ability to uncover the things that we're going to talk about, has really been a rewarding journey. I can't say enough about Bloom and Neo4j in general, because it really has accelerated us. We looked at a lot of different graph database technologies, and Neo4j has really hit a home run for us.
That's good. That's great to hear. Maybe speaking of which, how did you discover, or how was your path to graph? I mean, not only Neo4j but graph in particular, I guess. I mean, it's not a
Yeah,
turn left here or turn right here, and then there's a graph database, and then that's great.
It's
Usually
interesting. So back in about 2018, I was on a different security team here at Intuit, and we were using AWS Neptune, and it was really interesting. The challenges that we had were that it was slow, and back in 2018, it was noticeably different, but it was slower. Gremlin is really challenging to work with in comparison to Cypher. The visualizations, we spent a lot of time trying to come up with homegrown visualizations, and it was really a challenge. Fast forward a couple years, where I moved from the security group into a product team, and in the product team, we had these interesting infrastructure challenges, which spawned this need of ours to, instead of manually mapping out our infrastructure, we're diving into Akamai and tearing apart the configs and writing down manually something that would take us days to get a picture of our application. It was really frustrating. And so fast forward again to landing in the security team and being given the opportunity to try and solve that. Intuit does a really good job of allowing the engineers to do what are called global engineering days. And those GED days is where Zach and I hooked back up. He was still in the product team and I was in the security team again. And we said, let's solve this during this 1 week where Intuit just says, go work on whatever you want to work on. And we used Neo4j to solve this particular problem. At first it was graph databases. And we honestly, Neo4j was my last choice, because we're using Tiger Graph, AWS Neptune. AWS is kind of what we use here at Intuit. And those two things were the leaders, but Neo4j was so much better from our perspective that, I absolutely didn't want to use it because it wasn't the standard here at Intuit, but it made sense, and it made it easy. And it really was the clear winner for us.
That's great to hear. Thank you.
You have anything to add to that, Zach?
Yeah, Zach.
No, I think the only thing that popped into my head was as we were sitting here in the pre-show roll was going through, one of the things it talked about was like the whiteboard friendly modeling, right? And when we started trying to figure this out, right, we were like whiteboarding nodes and relationships and stuff, and at the time we just didn't know that that's what we were doing, right? And then as we started thinking about it more, we're like, oh, this graph technology is the way to start, breaking this problem down and figuring it all out. And that's what led us into, baking off all the different graph databases that Chad listed off and got us to where we are. So
it's interesting you say that too, Zach, because us whiteboarding exactly on the whiteboards led to, I really think that Arrows gives us that ability, because now we have a remote team in a different part of the world, and we're using Arrows as a way to do that whiteboarding and to do the nodes and relationships very easily. And the fact that you can share the embedded link from one person to the other and not have to recreate it or save it or find shared storage really is remarkable. And it really has accelerated our ability to communicate from a schema perspective. But I digress.
Yeah, but I think that's an interesting point that you made there, Zach. Is the whiteboarding is something that we keep on saying very intuitively. Okay, if you whatever you do on your whiteboard, you can take that and you take that into your graph database. But for us, it's clear. Okay, yeah, we work with Neo4j, we work with graph databases, so we see a whiteboard and any whiteboard really, and we say, oh yeah, that's a graph you got there. And lots of people don't make that direct connection. They use a whiteboard and they draw their circles and lines, and then they don't think this is a graph. They just think this is the whiteboard model, and then it has to go somewhere. And either it becomes a table eventually, or it becomes something else. But it's not not something for many people that directly relates into becoming a model for a database infrastructure. So
yeah, totally.
So that's cool. I linked the Arrows app in chat. So people, that's a tool we have developed since a while now, and it's available for everybody to use and to model, to maybe almost like a little digital whiteboard, like you are using it to try and see what the model looks like, how you develop it across teams digitally, or if you just don't want to mess around with, I don't know, paint or something on your local machine and draw it there, but you can use the predefined models. So it's relatively easy to use and very flexible in that way to adopt your graph as a model.
And just a plug for Arrows again, the user group we just did last week, one of the presenters, Jason Koo, he presented how to mock data using the Arrows app, and then how to integrate that with your development IDE and your workflow. So it was really interesting to see that level of taking Arrows, just a simple app that you can draw schema, but actually embed it into your development process as well. So it was kind of cool.
Yeah, totally. And I think the Arrows, and this is a little sidestep here, but I think Arrows became the de facto user interface for Aura now when we look at a data importer. So when you go into using Aura, Neo4j's cloud database service, then you get to start with Arrows derivative, basically, which helps you model your data and use a CSV file or other sources, and to get your data into your database. So it's very helpful to new users as well to find their way around the database, data modeling concepts by making it as easy as possible. So it's a success.
Yes. Yeah. Highly recommend it.
Yeah. Cool. So let's maybe talk about cybersecurity now. So you wrote this blog in November where you talk about the security vulnerabilities that you used to you mentioned this before. You map them out in a graph, and then that helps you track down these vulnerabilities. Is this what you said this was a challenge in the company, and this was like your project for a week, but
yeah.
I guess this was a challenge that was stuck around for a long time, and I guess lots of people always came back to it and said, oh, this is something we should look into, and then there was no real way of solving it, I guess.
Yeah, the real origin of it was when I was on the product team with Zach, and Zach, correct my memory here, but we got an important security alert on infrastructure that we were supposed to be managing, and this alert said, "Hey, this particular URL is exposing a vulnerability." So we immediately dove in and we're like, "Okay, well, where is this? How is this URL getting to our infrastructure?" And just like any other 10-year-old application, it's 10 layers deep. And so as we start diving into the infrastructure and the configs, we're like, well, this maps to that, and that maps to this, and this maps to this thing over here, and then that maps back over there. Mapping that out, in a legacy application that's like I said, 10 years old, becomes very challenging. And so one of the things that we wanted to do is what we call pierce the veils. So Akamai is one of those veils that we introspected. We pull out the configs, we pull out the data that's relevant. In this case, the endpoint mapping or the DNS names in the configs, and then we say this config has these names in it, and it maps across this infrastructure. And in doing that, it gives us the ability to see the infrastructure as a whole. And then, if we find another veil, as we call it, we would introspect that. We have some internal applications that do some similar proxying that Akamai does. And so we would pierce that veil. So we keep doing that. And as we did that, we continue to map out this infrastructure. And one of the things that we like to say is without visibility, we don't have any security. And so this visibility that we gain from this this inspection of the infrastructure is really powerful. Zach, you have anything you want to add to that?
Yeah, I think the only thing I'd add is, we find our way from an endpoint out on the internet like www.intuit.com through all these servers and routing layers and all this stuff that Chad talked about, and then from there we have access to who the people are at Intuit that are responsible for maintaining that. Like we tag our servers with who's responsible, what application it is, and all these sort of things like that. So we know who to reach out to, who to talk with, who to figure it out with, and figure out, is it a real issue? Is it something we need to patch? Whatever it might be. But getting to the people is really powerful as well.
Yeah, that attribution really has grown into its own thing for us in this security space, that the infrastructure mapping has turned into a whole platform of insights, and we're really growing towards attribution in that regard.
Yeah, I had a guest on this stream a couple of episodes ago, and they were doing access management, and they were saying, yeah, this is a real challenge. Is I don't know who is having access to what, internal only, but still, and how do they get access to what roles and rights do they have? What can they do? What can't they do? Does this person, is it supposed to be open? Should it be closed? Do they have access? Don't they have access? And it's a real mess even inside organizations. So I mean, yeah,
it definitely is. And one of the things that why Neo4j is useful for us is because it gives us the ability. There's a lot of tools out there that do this infrastructure mapping, but they seem to be siloed in. They can do this, but they can't do that. Akamai being one of them, and we haven't found yet, and maybe it's out there, but there's no tool that will give you that introspection from Akamai into your various clouds. And so Neo4j allows us to build an application that can sit on top of some of these other tools that then can bridge that gap. And some of the stuff that we've done with Akamai has even impressed the Akamai guys. They're like, wow, if we had this when Heartbleed happened, we would be able to do this mapping. We were having to do the same thing you're doing, and they still do map this stuff manually. Some people have scripts here and there, and it really feels like an area of growth that somebody can step in, and we hope to share our learnings. The blog post and the GitHub repo associated with was just a precursor to some of the stuff that we would like to share with the open source community around our learnings and how we're leveraging Neo4j and Python, and some of the ingest methods that Zach has developed really are novel and powerful. They really are powerful, and hopefully we'll get a chance to talk about the declarative ingest stuff that Zach has come up with. But it really is powerful and is eye-opening, and it helps us get that visibility from a security space.
Yeah, and we can totally talk about this today, and I'm looking forward to it as well. I think it's a how do you say, it's a curse and a blessing at the same time with all these open source tools and all these possibilities you have, and then you get. You as a developer, you can use these, and then you want to open them up, and then you want to use them, and then maybe have a little front end here or there and cobble something together, and all of a sudden you didn't realize that you have a huge security leak in your hands, but you don't think about it. You think, oh yeah, cool, I made this dashboard app, look at this, go to this page, and there it is. And underneath it's exposing critical data, and you didn't think of it. So it's
some of the value that we've added is we've gone from, like I said, days and weeks to mapping this stuff to now we can do it in seconds. We've exposed an API that sits in front of Neo4j, and it really has enabled us to accelerate things like attribution and ownership, and where an endpoint, relates to a GitHub repo, and to be able to say this source code is, from the 600,000 endpoints that we have on the internet, this GitHub repo that might have this vulnerability in it is tied to just these 5, or these 20. So we've narrowed it down in scope so significantly. So speed to remediation has vastly increased. So it really is something to be said.
Yeah. It's amazing, and I guess what you just said before with mapping out. I mean, you can start mapping some stuff manually, but it's 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 almost like a I don't know what the word is, Sisyphus job. It's, I guess you start somewhere and then the rock rolls down again.
Right, it definitely does. And one of the things behind the blog post that we were hoping to get out there was to give people just a taste of what they can do with Python and Neo4j using Akamai as the example. But there's no reason why you can't take that repo and ingest just generic data into Neo4j using Python. With just a few hours of work. So it really is something that I hope people take a look at and embrace. And some of the future open source stuff, I'm excited to see where we can go.
Yeah, me too. So
it might be good to talk about some of the ingestion stuff. I don't know if we have if you want to pivot to that now, but Zach, I would love to have you explain the declarative nature and why Python and those types of things. If Alex, if that's
no,
good.
Well, we totally,
yeah.
Okay.
So I did a nodes talk on this, whenever that was, a few months ago. If you want more details than what we can talk about today, but the general idea is that we have all these different APIs to different cloud services, even things like our internal extraction layers that Chad talked about, and a whole bunch of other stuff, right? And every one of those data sources has their own schema and their own language and ontology for the way data is declared and defined. And it really takes a subject matter expert in each one of those things to make sense of it and turn it into nodes and relationships. And if you keep doing this programmatically with hundreds of lines of Python for each data source, you are going to just spend your life calling new APIs and gathering data from it and turning it into nodes and relationship. And it's just not the most gratifying work. And it's an investment in time to add a new data source. We really wanted to speed that up and make it easier to ingest new stuff in a matter of an hour for some data sets, and maybe a day at most if you have to do some more complicated work. And so what we came up with is a declarative method of ingesting data. Basically, you have a record and you look at it and you say, this field means that it's connected to this node over here, and all of these fields are properties that we should put on this node, and these fields are things we should put on the relationship. And what it does is it iterates through all the records from a data source, and it'll do that work. It follows those instructions from a YAML file, and casts it into nodes and relationships and projects it to the database. So for the majority of new data sets, if you're coming off of a Kafka topic or an Amazon Athena table or a handful of other data sources, you can just declaratively project this data in sort of a developer-friendly, low to no code manner. And we've onboarded interns and other developers that have been able to do this for the first time in a day, and add new data. And when we're talking about this infrastructure stuff, it's coming from all kinds of different sources, like I mentioned before. And so we have, I don't even know how many, 40, 50 data sources from across the company and across our different vendors that we work with. And we collate it all together. Each one has its own little pipeline of data. And what we've done effectively is encode the subject matter expertise of each one of these tools programmatically and declaratively. So you don't need to retrain everyone on what it means, what this field means in relation to other data and all this sort of stuff. And we've been able to, I think it's one of the key reasons we've been able to succeed as much as we have, is that we've been able to easily add all this data and enrich other data with basically no code for the majority of them. So.
And when he says he doesn't undersell, or he doesn't oversell the fact. Just this weekend, there was a data source that we were given access to, pulling data from an S3, throwing it to a Kafka, and then pulling from Kafka and pushing it into Neo4j. I did it all within a few hours, and it included the arrows documentation, the schema updates, all of the things that the unit tests, everything. All of it was because of this declarative YAML configuration. I was able to do an entire ingest to ingest millions and millions of nodes and relationships within hours.
Wow.
It really is cool.
Yeah, that's super cool. Yeah. And I guess that helps with, makes it not like a, well, silo is a word that often is used, but not in this case. I mean, like more like it's an agile and a living application, because you make it easy to add new things to it. It's not somebody that has to, well, I have this new data set here, and then somebody says to you, yeah, of course, but well, put it on the pile, and then we'll see what's happening.
See when we can get to it. Yeah,
exactly. But it's
so easy. We'll ingest data just to see if it enriches the graph, and then we'll turn it off just because it's so easy to add it and remove it. That we'll do it as a matter of test even.
Yeah, one of the things that I like to say is, for those that have worked in a big company, you'll know that like cross-organizational projects are a nightmare, right? Everyone's got their own priorities and things take forever. Once we get that data, we can boil down what was a cross-organizational multi-quarter project to figure out who's responsible for what and yada yada yada, down to a database query that takes a couple seconds to run, right? And all that data is encoded. It's explainable how we got to these results. We know what data came from what data source and all of these things. And it's really powerful to be able to do that. It's increased the velocity of a lot of our projects in the security org. So
yeah, like what Dev Tedder says on the chat, it's like an accelerator. It helps each department. The cross-departmental gap sometimes is huge, and you want to work with the other teams, but they have their own agenda, you have your own thing, and it's not like fitting together well. But then when a project like this helps everybody equally, and everybody sees, okay, they're not, nobody has to wait forever for the other team to do something, and then you continue doing it there and then wait again. It is like a constant flow. Then I think it's super cool, and it's very beneficial to everybody in the end. Like in particular when it comes to security, like this.
I'd like to highlight one of the attributes that I think is the most important and beneficial in this cross-team, cross-organization collaboration. The ingest method that we have actually attributes the nodes and the relationships that it touches with the pipeline. So we can immediately tell you this node and this relationship in the graph is tied to this data source, and what where that data source is coming from. So the attribution in the ingest is one of the key features, I think, of the ingest model that we have, and it really has been helpful to make sure that we don't muddy the water and create yet another data swamp. This is a knowledge graph in Neo4j terms, right? We want to make it knowledgeable and useful, and hook multiple data sets together to, the sum of the parts. The sum of the parts is actually exponentially more beneficial than them alone. So it really is helpful.
Yeah, I think that's particularly true for you I guess use lots of internal as well as external data, but for internal data it becomes like oftentimes people don't feel like sharing as much, because they don't know, okay, why should I put this in there? And then this is my data, I have worked on it,
right.
It's my thing. But if I put it in and I get more out of it than what I put in, then it's a very good incentive.
Yeah, I think one of the challenges adding on to that Intuit has is oftentimes you can get the data, like we have a data lake and stuff like that, but it's who knows what it means, right? Like you can look at a record and have a name, and it's like, well, like is that this thing or is it another thing? Like what does it mean? And sometimes tracking down who the experts are and how that data got constructed and what each field means and stuff like that's another challenge. But with the graph, once we figured it out once, it's just the relationships are baked in, and we don't have to worry about deciphering data all the time. So
yeah. And then you also use, at least in the blog post, you use Bloom and the visualization part for it. Is that more in that picture? Maybe, I don't know. Maybe I can.
Yeah. So the visualizations in Bloom really, us gearheads, we like terminals, and we like, tables, and we like queries. But when you go to present to, executives or, directors, and visualizations are key in being able to show the relationships and draw even dynamically. One of the things that we did is we would create a safe cipher in Bloom, and the safe cipher in Bloom would give us, say, visualize this endpoint. And then the endpoint would just draw the infrastructure behind it. It would say, this is the endpoint. This is how it proxies through Akamai. These are the infrastructure pieces in AWS or in a different CDN, a third party behind Akamai. Bloom really gave that visualization. This particular visualization is
this one, right? This one here.
Yeah, so that's the visual. That's more like the visualize that we use to show the infrastructure mapping through Akamai, so that we could do the attribution all the way down to the GitHub repo. We wanted to say this particular endpoint is related to these GitHub repos and the infrastructure associated with it. The other visualization that you were showing is some of the attribution work that we're doing with regards to software bill of materials, or this library in this GitHub has this vulnerability, what CVEs are associated with it and what repos. Because now, since we can do this endpoint is tied to these repos, now if we can see what vulnerabilities are in the particular code that's associated with that repo, then we can see, we think that these vulnerabilities are potentially exposed on these endpoints. So it really gives us a greater visibility and a greater level of control around that. Zach, you have anything you want to say about that?
No. So I think earlier I mentioned that we can map servers to the people, and really how we do that is through what we call an asset at Intuit. An asset's just like a piece of software, more or less. And the asset has an owner, it has a development team, and it has GitHub repos. And then once we get to the GitHub repos, that's where we bring in other security tools and stuff like that to figure out what vulnerabilities may or may not exist on a given code base. So that's kind of the path that we walk, right? We take that host name all the way from the internet down into the bowels of our source code and figure out what's really going on underneath the hood.
Yeah, that was the two pictures you had on your blog. Good. All right. Cool.
One of the thing that pops to mind is one of the benefits of using Aura is there's been a lot of interest inside of Intuit, right? So we use Aura, and we use on-prem as well. But one of the benefits of Aura is when people see what we're doing and they want to try it out for themselves. Being able to spin up an Aura instance is very quick and easy, and it's allowed for people inside of Intuit to try it and to so to speak, kick the tires of Neo4j with a very low barrier of entry. The fact that Aura is so easily stood up really is a testament to its flexibility and being able to try it. So we continue to find good benefit there, and we are happy with our Aura instances.
That's good. That's great to hear. Yeah, I think that's one of the key ideas or concepts behind Aura, obviously, to make it as available as possible for many people, and to not have I need to set up a server and stuff like that. But obviously also with Aura free, to make it as easy as possible for any user to get started with the graph database, and to get just kick the tires, as you said, just register yourself, no need to set up something weird stuff you have to install or whatever else. You just launch it, you have your instance ready, and then you either use some sample data we provide, or you use your own you have around, and then get started with it. So that's
yeah, it brings to mind another thing, the NeoDash stuff. We use that on a daily basis. If you're not familiar with NeoDash, definitely dive into it. But we use that every single day in our agile stand-ups. We pull up the dashboard, we look at all the numbers because we've embedded the queries in there. It really gives us the visibility and control into how the systems are running and where we might be having issues and that type of stuff. So I'm just trying to think of the things as our journey. NeoDash really fit a need for us.
Yeah.
Aura has fit a need for us. Neo4j and Bloom, the Bloom visualizations really was a differentiator for us across all the other graph databases that we tried. So the suite of products that Neo4j offers really has helped us adopt and have the success that we've had recently. So it really is something.
I'd like to add that our success has gone well beyond just the infrastructure mapping that we've been focusing on in this. And in fact, a lot of that data forms the foundation of the other projects that we work on. So the things we've talked about, the infrastructure, the endpoints out on the internet, the code, the vulnerabilities, all these things. We've developed a scoring mechanism for our various assets to see what's the riskiest things and what's not.
Okay. Oh, that's cool.
Things. Yeah. So that was one project. We're doing a lot more work with attribution. That's where a lot of our things have dovetailed off into. And all the data kind of builds on itself, right? And what we have observed is, we have this foundational infrastructure data, and if we go and add this little bit over here and this little bit over here, then all of a sudden we can solve all these new problems, which is a lot more beneficial than building each small little system to do each one of these things individually, because we're duplicating a lot of work gathering the same data over and over and over again. And so we've gotten a lot. It's sort of snowballed in a lot of ways to produce things that we, like when we started this, we would have never guessed we were going to start working on. So
yeah. And you mentioned access management is a big issue from a security space, and that's one of our initiatives going into the next year is IAM inventory and mapping the access across the enterprise. And there's really cool things that we can do there. And we think that Neo4j is going to be the backbone of that that is going to enable us to achieve those things going into the next year.
Great. Good. I hope we can help you with all you need to achieve.
You guys have been doing a great job so far. So
that's good. That's good to hear. So and I don't know, you don't have to point out anything in particular, but was there anything you discovered with cybersecurity wise? We said, okay, wow, we didn't thought of this specific vulnerability being exposed, or we didn't thought of this was just anybody was using it, and then we realized, okay, because of having the flag up, we quickly discovered something that would have otherwise maybe could have caused something potentially more severe.
Zach, you got one? I have a couple in my head.
Yeah, I have one. I think one that we found a few things that people colloquially will say aren't around anymore. They've been shut off or whatnot, and we found evidence to the contrary, and that sort of stuff. So, things that linger, we've definitely found and removed where they should have been. So,
yeah. So I think the biggest thing that pops into my head is kind of, I think, some of the things that Zach is alluding to, but the hygiene, right? Where people will say something's turned off, or they'll turn off a piece of infrastructure, but they won't turn off the DNS, and so we'll have DNS that's pointed to something, or there'll be orphaned assets or resources in any. You look at any resource that we consume, an Akamai, an AWS, an ELB, an EC2, any of those things, finding orphaned resources is one of our bread and butter. Having that visibility allows us to ask the questions of, for instance, we asset tag all of the things so that we can correlate it to a team and a project. Well, we can identify what things aren't tagged very quickly, and we can even better. We can make educated guesses based on the relationships of things. We're like, well, this thing isn't tagged, but it's only 2 hops away from this thing that is tagged. So our best guess is this. And so, that's what somebody would have had to have done manually in the past, where we've put an API up and we say, these are the ranks. We're most confident about this one, but these other 3 are the next best in line. So it really has speed up our attribution and securing the products and the applications for our customers and for the company as a whole.
Yeah, very cool.
Yeah.
What would you say? I mean, you mentioned a few things. What would you say what would be the next step for it? Have you something in mind already, or is it more or less a little you see where it goes?
We have a few things. Software bill of materials is big, SBOM, and what we're starting to call there's an SBOM component and there's what we call RBOM, runtime bill of materials, right? Because where it runs and how it was built are kind of 2 different things, but married those 2 things together, that really is where some of the vulnerabilities can lie. And so we're diving into that IAM inventory and being able to say, hey, what access do people have? Should they have these things? We're also, investigating into some, rapid experimentation of like, hey, we think this might be a problem. Go and collect data and just fit it into the graph and see how it relates really quickly. So kind of these rapid deploy scenarios where we're going to go collect a bunch of data, fit it into the graph, and because the ingest model is so easy and declarative, we can test things. We like, oh, well, what does this say? In the future, I think that we're going to be able to run scenarios and be like, hey, what if somebody compromised this particular thing? Okay, what would be the blast radius of this particular thing being compromised, and being able to come up with a better overall risk score of, hey, what things can we tighten up to make sure that we're doing the best for our customers and for the company as a whole. So, Zach, do you have anything you want to say along those lines?
No, I think you pretty much nailed it.
Okay.
Yeah, that's cool. I think that's very exciting.
And it's really cool. I have to mention, working it into it and having the support of the leadership chain. When I say, we make security fun, it really is not. I'm not just tooting a horn or something like that. We actually walk the walk and talk the talk, right? So we're, the leadership all the way to the top is behind us. And we really are building a world-class security organization here, and I'm excited to see where we go in the next few years. It really is something.
Yeah, me too. I think that's going to be a very interesting space. Very interesting to watch what comes out of this, and that's maybe also leads me to the next question almost perfectly. Is you have a GitHub repository, you have some people can follow you and at least take what you open sourced and copy that over and try it with their own organization. What would you say is
so that's just a taster, and we released it to give people something that they could play with. I'm going to let Zach talk about some of the plans that he has with some of the open source stuff that we're planning in the next year. It really is going to enable people to accelerate their adoption of Neo4j and security as a whole, I think.
Yeah. I think one of the big things is our ingestion engine, I think, is kind of one of their key recipes to success. And we have a couple other teams in the company that are planning on using that as well. So right now we're in the process of extracting that to a consumable library internally. And that's basically going to let us go through the process of cleaning up the documentation and making it consumable for other groups of engineers and stuff like that. And I think from there it'd be a fairly natural transition for us to open source that and make that available more broadly. So that's one of the big things I think we're working on. And with that comes like a whole toolkit of things, consuming from different data streams and from data lake stuff, and all this declarative ingestion stuff. Everything's kind of one big package of tools you can use that we've built to ingest data into the graph, and then from there it's you just kind of wire it into your different data sources and you're off to the races. So I think that's our biggest first step, is to get that out and garner feedback and collaboration and contributions from others. So
yeah, I'm really excited to get that out and to share some of the clients that we've developed, interacting with S3, interacting with Kafka, interacting with Athena, interacting with some of our normal data ingest, and doing it in such a declarative way that it really is designed to take data from one place and put it into Neo4j and allow you to use it however you want to use it. There's no, we're not opinionated on how you use your data once it's in the graph. We're not trying to sell a product. We're not doing anything. We're just trying to make the space easier to adopt and to share our learnings. It really is cool.
One thing to add, like right now, we're going through the strain of optimizing our ingest performance, and we've talked with some of the folks at Neo4j, and we've got all these little tricks, and I don't want to say hacks, but tools of the trade to optimize the way that we do stuff, and increase the performance and throughput of all of our ingestion and stuff. And that's not something I'd wish on anyone else to implement. So, having that as an accessible component that people can just consume is going to be powerful. So
yeah, that definitely can be very powerful. I guess we have a follow update once you gone live and it's available. Then we probably should talk again and see maybe with a well, obviously this wasn't possible today because the data is confidential, but then the data won't be confidential, and then we can maybe show a few things, how it's done, how to connect sources, and give a hands-on.
So that starter GitHub is kind of a taster, and it will be similar to that. So if you can grok the declarative nature of that taster GitHub repo, then you'll understand the future open source stuff that we release.
Yeah. Very, very exciting. I'm definitely staying in touch and hope this goes, where this goes. Would be exciting to see. I have a question from chat, so maybe we can do that.
Sure.
DevTedder wanted to know what was the methodology to extract, differentiate, separate, and make analytical decisions that were beneficial to identify the trouble issues like Akamai Endpoints, Vulnerabilities, FQDNs.
So the tactic that we took was we try and do it coarse grained. We say, okay, of the 600,000, let's narrow it down. And what we did is we ingested the configs, we picked out the DNS names that are coming into Akamai, and then where they routed out. And from there, we say, okay, we know this config is allowing access in the front door to these names. And on the back end, it's routing somewhere, we don't know where, routing somewhere to infrastructure behind it. What that gave us the ability is to remove that Akamai abstraction layer to say, we know that these, let's just say 10 endpoints or 5 endpoints route to these 5 to 10 endpoints behind it. Now we've narrowed 600,000 down to 10. And then even then we've narrowed it down to just the 10 behind it. So it really gave us the ability to quickly narrow our focus, which is, it gives us more time to invest in the right areas as opposed to just sifting through all the needles in the haystack, right? I don't know if that answers that question directly. Zach, do you have anything, thoughts there?
Yeah, I think it's mentions differentiation and making the decisions on like the trouble spots. I think the other thing I would layer in is the risk scoring mechanism that we've developed. We look at a lot of different data to figure out what's the scariest applications in our company, and I don't mean that in the sense that they're full of security issues. What I'm saying is that this is an API that sits out on the internet and exchanges information with banks, right? That means it holding on to and operating on very sensitive data. It's exposed on the internet, right? The nature of that application carries with it a certain risk. And by creating a metric around that, it helps us prioritize things and cut and slice the information in different ways to figure out how we should prioritize time and what things need deeper levels of review and analysis from our security architects and folks versus things that are internal and more sheltered and may not necessarily need the same level of rigor. So I think that would be the other big thing I'd add.
Yeah, and just to add on to there, just knowing that these endpoints are exposed on the internet is a data point that we use in that risk factor. Or we know that these ones are exposed on the internet, but these ones are protected by WAF, or these ones are not. And just those differentiations, those data points allow us, since it's in the graph, we can just simply issue a query to the graph and say, give us all the endpoints that are protected, that are on the internet but are protected by WAF, and are on the internet but aren't protected by WAF, or that type of stuff. So it really gives us the visibility that we need to make those determinations from a security perspective.
Okay. Yeah, very cool. Zach, you mentioned you are giving the security kind of like a scoring. Are you using graph data science any algorithm for this, or do you have your own scoring system?
Yeah, so we developed a scoring system around a survey that developers can fill out, and basically depending on what your answers are to the survey, you get a certain score. Like each answer has its own sort of weight, and what we do is, when a developer doesn't fill out the survey for older things, or it's a new application that they haven't done it, we infer the score using the graph. And so we basically guess what they would answer if they were to answer it, and then use the same numeric values that we would apply from the survey. And so it's not graph data science. We've explored it and looked into it. I think we'll come back around to it at some point for some other things, but not currently.
Okay, cool. Okay, I think we come almost to an end now. Anything you wanted to say before we wrap it up? Anything we didn't mention? Anything important?
No, I think I would just reiterate I appreciate the partnership that Neo4j has given to us. Our support team with Daniel Kang and crew are just amazing. Alex, I appreciate you giving us the opportunity to come on here and talk about some of the exciting things that we're doing. I really think that Intuit is building, like I said, a top-notch security organization, and I see Neo4j as one of those backbone components that enables us to be successful. So I appreciate everything you guys do. I love the product, and I'm excited to see where we go.
That's great to hear. Thank you very much. I mean, absolutely, the can only give this back. I mean, you wrote the blog post. You made this. You told the story. You need people who tell their stories. We need to hear about it, and I'm happy to have you join. So I guess it's like, if you're watching this now and you think you have a great, interesting Neo4j story or graph database story, well, sort of Neo4j, but it should involve Neo4j, right? But then write about it or hit me up on the social media and let's talk. I'd like to let the world know, and this is really good. So yeah, thank you, Chad, thank you, Zach, for writing that post, for making that effort, for speaking at Nodes past time, and for obviously being here today. So it's been my pleasure.
Awesome. Thank you so much.
Cool. Thank you very much. Have a good rest of your week, everybody. And yeah, thank you for watching. And one more question. Maybe we'll do the question. Oh, well, we did the question. Stink fruit. Animal in chat's had. What is that? A beaver? Yeah, I guess it's.
Yeah. So this is to promote the Intuit security team here at Intuit. We make it fun, and come join the Bidoof Brigade. So this is Pokemon, the Bidoof Pokemon. So.
Very good. I like that. I think definitely that's very cool. Good. All right. So that's cleared out. So yeah, thank you very much, Chad and Zach, and everybody for watching. And I hope to see you again soon in another live stream. join the workshop trainings if you wanted to get something hands-on. And next week, to highlight a few things that's happening on the stream, I will be doing another stream with Michael on the Monday. On Tuesday, well, it's a very busy week next week. On Tuesday, we have a Going Meta episode 14. So if you're interested in knowledge graphs and ontologies and all of that stuff, then Tuesday is your day. And on Wednesday, we have a Women in Tech, Neo4j Women in Tech, a special live stream because it's International Women's Day on the 8th of March. So that's happening next week. Until then, take care, everybody. Thank you for joining. Thank you again, Zach and Chad, and see you soon. Bye.
See ya.